All right, let's dive into these Hubble images. I am so ready for this.
Me too.
Yeah.
There are some real stunners in this batch.
Seriously. It's like a cosmic postcard collection, you know?
Yeah, and they're not just pretty pictures.
Right.
Each one tells a story about the universe.
Exactly. Oh, before we jump in, I just want to remind everyone that we're going to be getting into some pretty in-depth stuff.
Oh, absolutely. This is definitely a deep dive, but don't worry, we'll guide you through it.
Yeah, we're going to break it down so everyone can follow along.
Exactly.
Okay, so our first stop is in the constellation Aquarius, home to, well, a pretty wild binary star system called R Aquarii.
Oh, yeah, that one's a showstopper.
And I think what really caught my eye was this crazy nebula surrounding the stars. It looks almost like, I don't know, a cosmic fingerprint.
That's a great way to describe it, actually.
Mhm.
What we're seeing is a red giant star and a white dwarf companion.
Okay, so two stars, but
But they're not just hanging out peacefully. They're locked in this gravitational tug of war.
a tug of war, huh?
Yeah. And the white dwarf, it's actually pulling material off the red giant.
Like stealing it?
Yeah, you could say that. It's like a cosmic vampire star.
Oh, I like that. So that chaotic nebula,
That's all that stolen material swirling around.
wow. So it's not just a snapshot. This image is capturing this dynamic process happening.
Exactly. And it's causing these crazy brightness variations that have astronomers just baffled.
Oh, really?
Yeah, imagine trying to predict when, like, a light bulb would suddenly get brighter or dimmer for seemingly no reason.
Oh, that's wild.
That's what we're dealing with here.
Oh, okay, that's amazing. Okay, now I have to ask about Omega Centauri. I mean, a globular cluster that's visible to the naked eye.
Right.
How is that even possible?
Well, it's because Omega Centauri is absolutely massive. It's the biggest and brightest globular cluster in our galaxy.
Like, how many stars are we talking?
10 million stars, all bound together by gravity.
10 million.
10 million.
So if you could travel to the center of a globular cluster like that.
Oh, you wouldn't need a flashlight, that's for sure.
Right, just a sea of stars. That's wild. But here's where things get really interesting.
Okay, I'm listening.
Omega Centauri, it might not be a typical globular cluster.
Okay, what do you mean?
Some astronomers think it could be the core of a disrupted dwarf galaxy.
Oh, wow. Like a whole galaxy got shredded.
Yeah, leaving behind this cluster of stars.
That's insane. So it's not just a stellar nursery. It's like,
A galactic graveyard.
yeah, almost a remnant of some ancient cosmic battle.
Whoa, that gives a whole new meaning to star cluster. And it makes you wonder if other globular clusters have similar stories.
It really does. Every object in the universe has this whole history, right? And sometimes that history involves these epic events that leave their mark on, well, everything.
Absolutely. Okay, so we've covered a dramatic binary star system and a potential galactic remnant. Now, let's talk about the ultimate cosmic heavyweight, a black hole.
Okay, let's do it.
And not just any black hole, but the one in Galaxy M87, where we got that groundbreaking image a few years ago. The first ever image of a black hole.
It was a monumental achievement. And, we can't see black holes directly because they are by nature invisible. So what we captured was the black hole's shadow.
The shadow.
Yeah, like the silhouette it casts against this glowing gas surrounding it.
Okay, I'm trying to wrap my head around that. It still blows my mind that we can even image something like that.
It took incredible technology and collaboration.
Yeah.
I mean, we basically linked telescopes around the world to create this virtual Earth-sized telescope.
Wow. So like a giant eye peering into the heart of this galaxy. That's just incredible.
It is. And what makes M87's black hole so special is that it's what we call a supermassive black hole. It's millions or even billions of times more massive than our sun. And it's incredibly active, producing these powerful jets of energy.
Jets of energy? What does that even look like?
Imagine, like beams of light shooting out from a lighthouse, but on a cosmic scale. These jets extend for thousands of light years. They carry energy and particles so far beyond the galaxy itself.
Okay, so it's not just sitting there passively, it's actively shaping its surroundings.
Exactly. And Hubble, its observations have been crucial for studying these jets and understanding how black holes influence their environments.
Okay, now I'm picturing black holes not as these like cosmic vacuum cleaners, but as dynamic forces that are shaping the evolution of galaxies.
Yeah, that's a great way to think about it.
That's amazing. And speaking of galaxy evolution, let's move on to two galaxies that are practically bursting with new stars.
Which ones?
NGC 5253 and NGC 1672.
Oh yeah, those are great examples. They're both showcasing intense star birth, but they're very different in their structure.
Okay, so tell me more.
Well, NGC 52253 is what we call a starburst galaxy, meaning it's experiencing this super high rate of star formation, like a stellar baby boom on a galactic scale.
Wow, a galactic baby boom. So what triggers this kind of star formation frenzy?
In a lot of cases, it's galactic interactions. Galaxies, they aren't static. They move and collide. And those encounters can spark these bursts of star formation.
So it's like two galaxies get close enough and it's like, boom, a whole bunch of new stars are born.
Exactly. Now, NGC 1672, the barred spiral galaxy. It has this striking bar-shaped structure at its center.
Okay, I'm picturing it.
And that bar plays a key role in funneling gas towards the galactic center, which fuels even more star formation.
So it's like the bar is directing traffic, making all the gas and dust pile up in the core.
Yeah, it's a great analogy. And these different types of galaxies, it really showcases the incredible diversity we see in the universe.
It's amazing how Hubble can reveal these tiny details about galaxies that are millions of light years away.
It is incredible, isn't it?
What else have we learned about NGC 52509 and NGC 1672 from these images?
Well, by studying the light from these galaxies, we can actually learn about the types of stars being born, their ages, and even the chemical composition of the gas that's fueling their formation.
So it's like taking a cosmic fingerprint.
Exactly. And those fingerprints, they provide clues about the galaxy's histories, how they've evolved over billions of years, and how star formation varies across different types of galaxies.
So we're not just looking at pretty pictures, we're piecing together the evolutionary stories of these cosmic structures.
That's exactly it.
This is incredible. Okay, our final stop for this part of our deep dive, NGC 3810.
Ah, another spiral galaxy.
But this one has these really prominent dust lanes swirling around its bright core.
Oh, yeah, those dust lanes are gorgeous. And they're scientifically valuable, too.
How so?
Well, they're like cosmic highways. They trace the paths of gas and dust within the galaxy.
I'm trying to picture it like rivers of stardust just flowing through the galaxy, feeding the formation of new stars.
Yeah, that's a great way to visualize it. And by studying those lanes, we can learn about the galaxy's structure, its dynamics, how material flows within it.
It's incredible to think that those dust lanes are hiding even more stars and wonders within that galaxy. Secrets just waiting to be revealed, you know?
It really highlights how much there still is to discover. Even with Hubble's amazing vision, we're only seeing a fraction of what's truly out there.
It's true. Okay, so this has been an incredible journey already, and we've only just scratched the surface. We'll be back in part 2 to delve even deeper into these Hubble discoveries.
Welcome back. Ready for more cosmic adventures?
Oh, absolutely. It's like we have backstage passes to the universe's greatest show.
It's a great way to put it.
And we left off talking about NGC 3810 with those captivating dust lanes hinting at all those hidden wonders within. It just makes you wonder, you know, what other secrets are tucked away in those images just waiting to be decoded?
Yeah, it really highlights the fact that even with Hubble's incredible vision, we're only seeing a small piece of the puzzle.
It's true. Okay, so we touched on black holes earlier with M87, but what else has Hubble shown us about these cosmic enigmas? They've always kind of had this mystique for me, you know? These regions where gravity is so strong that even light can't escape.
Black holes are definitely captivating, and for a long time they were purely theoretical. But Hubble has been instrumental in confirming their existence and helping us understand how they behave.
So it's not just proving they're there, but figuring out how they work, their role in the universe.
Exactly. And one of the biggest revelations has been the discovery of supermassive black holes at the centers of most, if not all, galaxies.
Really at the center of galaxies?
Yeah. These are black holes that are millions, even billions of times more massive than our sun.
Wow. Okay, I'm trying to grasp the scale of that. So these supermassive black holes, they're like the anchors of galaxies. Does that mean our Milky Way has one too?
It does. And Hubble has helped us study its motions. That's actually how we got evidence for its existence, and we were able to estimate its mass.
That's mind-boggling. I always imagine black holes as these kind of, I don't know, isolated monsters just lurking in the darkness. But you're telling me they're at the heart of most galaxies, including our own. So what does that mean for the galaxy itself? Does it affect how it behaves?
It absolutely does. Supermassive black holes are thought to play a crucial role in the evolution of galaxies.
I thought they were just destructive.
Well, while they have this reputation for being destructive, they can also be engines of creation.
Okay, hold on. How can something that devours everything in its path also be creative?
It's all about the energy they release. As matter falls into a black hole, it heats up and emits this incredibly intense radiation. And this can trigger powerful outflows of gas, which can both suppress and stimulate star formation in the surrounding galaxy.
So it's like a cosmic balancing act, this dance between destruction and creation.
I like that. Very poetic way to put it. And Hubble's long-term observations have allowed us to actually witness this interplay in action. We've seen evidence of these outflows shaping the structure and evolution of galaxies over billions of years.
Oh, wow. That's incredible. Okay, we've talked about black holes and galaxies, but what about those dazzling globular clusters? They're like mini galaxies unto themselves.
They are fascinating, and Hubble's high-resolution vision has allowed us to study individual stars within these clusters, which has revealed a surprising level of diversity.
Diversity. I thought globular clusters were just filled with old stars, all born around the same time.
That was the prevailing theory for a long time. But Hubble has shown us that some globular clusters, like Omega Centauri actually, contain multiple generations of stars with a range of ages and compositions.
So it's like a family reunion where not everyone's actually related. Some folks just wandered in from a different party.
A fun analogy.
Yeah.
But yeah, these different stellar populations suggest that globular clusters have a more complex formation history than we initially thought.
So they're like preserving a record of their galaxy's past, like cosmic time capsules.
Exactly. And by studying the stars within these clusters, we can learn about the early universe, the conditions that existed billions of years ago.
It's just incredible how Hubble, a telescope orbiting Earth, can unlock secrets about objects so far away and so far back in time.
It's pretty amazing, right? And speaking of history, let's not forget the human element in all of this. Behind every Hubble image, every discovery, is a team of scientists, engineers, technicians who've made this mission possible.
It's a testament to human ingenuity and our enduring curiosity about the universe. It makes these images so inspiring, don't you think?
They remind us that we're capable of incredible things when we work together.
Absolutely. And you know what? These discoveries have really captured the public's imagination, too. The Hubble images, they've become iconic. They've inspired art and music, even fashion.
Yeah, they become a cultural touchstone, a way for people to connect with the vastness and wonder of the universe, even if they're not scientists themselves.
It's like these images have given us a new perspective on our place in the cosmos.
Absolutely. They remind us that we're part of something much larger than ourselves.
It's humbling. And it makes me appreciate the dedication of the people behind Hubble, the ones who made all of this possible.
They're true pioneers. They push the boundaries of what we know.
Exactly. And hopefully, future generations will have even more powerful tools to explore the universe. What do you think the future holds for space telescopes? What kind of mysteries are out there waiting to be discovered?
Well, the future of space exploration is incredibly exciting. We have new telescopes on the horizon, like the James Webb Space Telescope, which will allow us to see even further into the universe.
And unravel mysteries that Hubble couldn't quite reach.
Exactly.
I can't wait to see what they reveal.
Me too.
Huh.
There are countless wonders out there just waiting to be discovered.
Well, on that note, we're about to reach the final frontier of our deep dive into Hubble's latest revelations. Wow, this deep dive has really flown by. It's amazing how these Hubble images have taken us on such a journey.
Yeah, it's incredible what we've been able to see and learn just from looking at these pictures.
Right. We've zoomed in on stars being ripped apart. We've contemplated the shadows of black holes. We've even glimpsed the echoes of these ancient galactic collisions.
It's a testament to Hubble's power, that's for sure. It reveals so much about the universe, both big and small.
It really does. And as we've been talking, I keep thinking about how everything's connected out there.
Oh, absolutely.
Like those starburst galaxies we were discussing,
Yeah.
their intense star formation, it's not just a local event, it's got these ripple effects across the entire cosmos,
Well,
right?
no, the starburst galaxies are like giant factories churning out these heavy elements.
To the element.
Yeah, the building blocks of planets and life as we know it. And these elements, they don't just stay put. They're dispersed by these powerful galactic winds.
Oh, wow.
And they enrich the surrounding gas, seeding the next generation of stars and planets.
So it's like a cosmic recycling program?
Exactly. The death of one generation of stars provides the ingredients for the next.
That's wild. But how do we even know what these elements are? I mean, we're talking about light that has traveled for millions, even billions of years. How can we decipher that information?
That's where spectroscopy comes in. Think of it like taking a rainbow and analyzing each color very carefully.
Okay.
Every element, it emits and absorbs light at very specific wavelengths, creating a unique fingerprint. And by studying the light from these distant galaxies, we can identify what elements are present and even figure out how abundant they are.
So it's like, what, cosmic forensics?
Uh-huh. Yeah, a very good analogy. We're using light to reconstruct the scene of events from billions of years ago.
That's pretty cool. And I imagine these analyses have yielded some pretty surprising discoveries.
Oh, they definitely have. We've learned that the chemical composition of galaxies has actually evolved over time.
What do you mean?
Well, the earliest galaxies, they were primarily made up of just hydrogen and helium, the simplest elements. But as generations of stars lived and died, they produced heavier and heavier elements, enriching the cosmic mix.
So the universe is actually getting more complex over time.
In a way, yes.
That's kind of beautiful, isn't it? This cosmic evolution, not just of stars and galaxies, but of the very elements that make up everything we know.
It is a beautiful concept.
Yeah.
And Hubble has played a key role in revealing this story. And it's not just about looking back in time. By understanding how galaxies have evolved, we can actually start to make predictions about their future.
Their future.
Yeah, how they'll continue to change and interact over billions of years.
Wow. So we're not just passively observing the universe, we're actually starting to grasp its underlying principles, its grand evolutionary arc.
That's one of the most exciting parts of science. It's not just about collecting facts, it's about understanding the bigger picture and figuring out where we fit into it all.
That's true. It really is humbling. And it makes you appreciate all the amazing people behind Hubble, the scientists, the engineers, all the people who've made these discoveries possible.
Absolutely. Their work has inspired countless others to pursue careers in science and engineering.
And ensure that this quest for knowledge keeps going.
Exactly.
And speaking of the future, what do you think is next for space telescopes? What kind of mysteries are still out there waiting to be solved?
Well, the future of space exploration is incredibly exciting. We've got new telescopes coming online soon, like the James Webb Space
Oh,
Telescope.
yeah, the James Webb.
It'll allow us to peer even deeper into the universe, unravel mysteries that even Hubble can't quite reach.
Wow, I can't wait to see what they discover.
I know, it's going to be incredible.
Well, I think it's time to wrap up our deep dive. Thank you so much for taking us on this journey.
Oh, the pleasure was all mine. It's always a joy to talk about the wonders of the universe.
It really is. And to our listeners, thank you for joining us on this deep dive. We hope you've enjoyed exploring the cosmos with us. And remember, keep looking up, keep asking questions, never lose your sense of wonder. The universe is full of secrets just waiting to be discovered. And who knows, maybe you'll be the one to unlock them.